If you've ever worked on a Commodore 64 that was broken, you know that the biggest problem that these machines seem to get is the dreaded black screen. A failure mode that basically offers you no information about what's wrong with the machine, and it can make the machine a little bit tricky to diagnose if you're not familiar with it. There are a couple diagnostic ROMs that are very popular for people to use. The regular diagnostic ROM, which requires a mostly working system and a diagnostic test harness for a complete diagnosis. There's also the DesTest ROM, which this double-sided cartridge has both on it, that allows you to hopefully get a little bit of insight into what's wrong with your Commodore 64, even if it just turns on to a black screen and can't run the more full-featured diagnostic ROM. Well, when I was recently at VCF Midwest, someone walked up to me and handed me a packet, and inside of it was this diagnostic ROM cartridge. And after playing around with it, I feel that this ROM cartridge is probably the biggest step in Commodore 64 diagnosis that we've had in a very long time. So in this video, I want to take a look at this ROM, see what it's all about, and see if it really does deliver on its promise. So without further ado, let's get right to it. Let's start by taking a look at the regular diagnostic ROM and then the Commodore DesTest ROM, both of which I have on this double-sided cartridge. Currently, this computer is working perfectly. Let's just double check that real quick before I start anything, because you always need to make sure that your 64 hasn't broken before you try to do any testing. Okay, there we go. Things are working properly. So first I'm going to insert the regular diagnostic cartridge. This is the one that you would normally run with the diagnostic test harness, and it gives the most comprehensive test of the 64, especially when you're using the harness. It tests all the ports and whatnot, plus the RAM and everything else that's on the motherboard. The problem with this test, though, is you need a nearly fully functional 64 for this to operate properly. I'll demonstrate that by just simply removing the kernel ROM on my machine. Now, if your kernel ROM were, say, damaged and you tried to use this ROM, there you go. You get the dreaded black screen. Well, this is where the Commodore DesTest ROM comes into play. I'll just flip this cartridge around and I can demonstrate the DesTest ROM. What the DesTest ROM does is it puts the Commodore 64 into Commodore Max mode. The Commodore Max was a precursor to the Commodore 64 and was essentially just a games machine. I think it only had 2K of RAM and a more simplified design. The 64 is fully backwards compatible with all Commodore Max game cartridges, and there's a signal that the cartridge can assert that tells the PLA to put the computer into Commodore Max mode. When you're in Commodore Max mode, it cuts down on the requirements for what peripheral chips need to be installed in the system, because the cartridge is now able to replace many of those chips. All of the ROM chips on the motherboard fall into that category, and in addition, you don't need to have working 6526s or a working SID chip for the system to operate. Now, one of the issues with the DesTest ROM, though, is when you turn the machine on with it in there, and I'll just recycle the power, is you get this black screen for a while, which means that if there's a fault on the machine that prevents the DesTest from running, sometimes you're left just sitting here waiting for a while before the user interface comes up, which is what we're looking at here. Now, the premise on the old Commodore DesTest ROM is that if there's a problem with the DRAM on the system, and I'll just take one of the chips out here, the code that's on the ROM, at least in that initial phase where you have a black screen, doesn't rely on the DRAM to actually run. So no zero-page locations or stack pointers are being used. So if we turn on the system now, we immediately get flashing. And if you go refer to the manual for the DesTest ROM, it'll tell you that that flashing correlates to this chip being removed from the motherboard. Now that's all fine and good, but it means that for a novice, you have to sit there trying to count the flashes and hope that the information that you're getting from the flashing screen is accurate. The other thing about it is it really only flashes one bit at a time, and that's because the RAM test that it does is extremely rudimentary. So you might have no RAM on your motherboard at all, or several bad chips, and you're gonna get kind of random flashing depending on which chip it detects as bad first. I think the general premise back in the day when the ROM was made is that you would fix the bad RAM chip, restart the ROM test, and it would flash a different code. You would fix that chip and, rinse and repeat. Now, if you're a regular watcher of my channel, you've probably seen my videos on the diagnostic ROMs that my friend David Giller created for other systems. And that's because I have found that while the Commodore has these two tests, which are, decent, other systems just seem to have very inadequate diagnostic ROMs. So we set out to create better diagnostic ROMs for these other systems, like the TRS-80 Model 1, 3, and 4, and the TRS-80 Model 2. Those are slightly different architectures, along with the Apple II, and most recently, the IBM PC. And one thing that I think is really awesome about all those diagnostic ROMs that David Giller has recently implemented that I've shown on the channel is that they use March testing to do the RAM test. This is a very thorough and somewhat modern RAM testing methodology that promises to catch all sorts of subtle problems with the RAM that regular pattern-based RAM testing doesn't catch. Now, while the 64 has these particular diagnostic tests that I've just shown, the issue is the RAM test they both use is very primitive pattern-based testing and not the much better March testing that promises to catch things like page error and other subtle errors. So there are plenty of times when these diagnostic ROMs might say your system is fine, but it's actually unstable and crashing because there is a subtle RAM error. So that's where this new diagnostic ROM steps in. This was created by Matt Desmond, who's somewhat famous in the Commodore community for making some really awesome Commodore software in the past. Matt walked up to me and handed me this cartridge here, along with the documentation for it, and his new ROM called DesTestMAX implements March testing on the Commodore 64, but goes one step beyond compared to the DesTest ROM and actually gives you a visual indicator of what's happening from the very moment you turn on the system. Let me demonstrate it. It's freaking awesome. So this ROM in its current iteration operates exactly like the DesTest ROM in Commodore Max mode, and that's why it's called DesTestMAX. So with the cartridge in the system, when I power it on, immediately we get this screen here saying that it's doing its test thing. When it's powered up, it quickly does some tests just to make sure that the ROM checksum is good and everything like that, and it will report if there's an error. And then it goes on to test if the VIC is working properly as best as it can, and then it tests for the 0 page and the stack page. And it uses the overall border color to represent what phase of the test it's in, from gray, blue, and then purple. Now what's happened here is you notice the border is blue except for these bars that we see here. That means that it failed in the 0 page test phase. Now on 6502 based systems, 0 page is the first 100 bytes of memory, and that part of memory is very critical to the operation of a system. As soon as the system tries to boot, if you have the kernel ROM inside the machine, it's going to use that part of memory to, well, basically run the system. And if that part of RAM is bad, immediately the system is going to crash and most likely result in a black screen. The second 100 bytes of memory on 6502 based systems is used for the stack and the stack pointer. Anytime you do jumping subroutines in assembly code where you need to jump back to what you've done after you've finished, needs the stack to work, because assembly code will typically push things onto the stack and pop it off the stack. So not only is a processor using it, but also assembly code uses that part of the RAM as well. So just like with the 0 page, if the stack is somehow misbehaving, then your system is not going to operate either. And that's why the diagnostic test here tests those parts of memory right off the bat. Now this is where things are really cool. On the DesTest ROM cartridge, when I put it into this machine with the RAM chip removed, all we got is a flashing screen. Didn't get a whole lot of information on what exactly is going on, but what Matt was able to do is utilize some extra functionality of the Max mode on all Commodore 64s to actually display text on the screen, even though you can have no working memory, which normally isn't really possible. Let's talk about that a little bit. The reason why that's a big deal on the Commodore 64 is because the VIC-2, which in this case it's an FPGA, but you can imagine it plugged in right there, it uses the main 64K memory for its display buffer. So any text you see displayed on your CRT or through the video output is actually stored in the memory. That means if you have no working memory, say I took out all of these chips, there would be no way for the VIC-2 chip to display anything at all. This is different than a lot of other systems where there is actually dedicated RAM used specifically for displaying text and graphics. Think about that in like the PC architecture world. The MDA, CGA, EGA, and VGA cards all have dedicated RAM on the card itself that is used for displaying text and graphics. So with the RAM test ROM that David Giller wrote for the IBM PC XT, which I've recently showed on the channel, the way it's able to work and display stuff on screen is it actually uses that video memory on your video card to help run the diagnostic ROM code. It doesn't rely on the RAM on the motherboard at all. The same goes for machines like the TRS-80. That also has dedicated video memory as well. So we're able to use that to help run the diagnostic ROM. Also, the 8088 and the Z80 processor has some more flexibility over the 6502, where you can point the stack to any arbitrary place in memory. Therefore, you can actually point the stack to the video memory itself, and that allows you to, well, run your diagnostic ROM and have the ability to do subroutines and things like that. Now on the Apple II, it works very much like the Commodore 64, where there's no dedicated video memory at all, and it relies on the 0 page and the stack page, that first 100 bytes and then the next 100 bytes of memory for the operation of the ROM. So in a very similar fashion to this, the DesTest ROM that David created for the Apple II does do some rudimentary testing on those parts of memory first, and if it determines that the memory looks okay, then it tries to draw some text onto the screen, which is using the main memory, and then go through some routines to do March testing on all of the RAM, and then displays a status page to tell you what's going on. If an error is detected on the Apple II in that first 100 bytes of memory or the second 100 bytes of memory, it uses beep codes through the speaker to tell you that that is where it has detected a problem, and it tells you what bit is bad. It's very similar to what Matt's doing here with this, but he's using a special trick of this max mode to actually display text on the screen and give you an indication of what bit is bad in the border region. And you can see that this is telling us here that bit 2 is the one that is the problem. And yeah, that's the chip I removed from the board. Now bit 2 refers to data bit 2 on the CPU. And of course, depending on what 64 you're using, the chip that's affecting might be different. Some 64s only have 2 RAM chips and each chip has 4 bits in them each. So you have to check the schematics to see which bit from the CPU is connected to which RAM chip on the board, so you can get an indicator of what's actually bad. Why don't we go ahead and pop out all 3 of the RAM chips that are in sockets on this board. That unfortunately is all that is socketed, so I cannot take all the memory out to demonstrate that this test can run with everything removed. And now with these 3 chips removed, you can see that it's indicating that bits 1, 2, and 7 are all bad. Very helpful information, and it also gives us a good idea that while this machine, if I even with the kernel ROM back in and the cartridge removed, we just sit here on a black screen. And remember, if I put in the DesTest ROM, we will get flashes right now, but we're not going to get too much else. And with the cartridge back in and we turn it on, there we go. A nice friendly indicator of what RAM chips are bad on the system. So you might be asking now, how is Matt displaying text on the screen without having access to any working system memory? Well, apparently there is a feature in max mode, which is the mode that the DesTest and this ROM operate in, that allows the VIC to actually point to screen memory that is in the ROM cartridge itself. So the DesTest ROM and this cartridge replace the kernel ROM in the system. So the PLA needs to be working for that to happen. The PLA looks at the signal that comes from the cartridge, disables the ROMs on the motherboard, and then uses the cartridge ROM in the place of the kernel. So the CPU boots directly into the ROM that's on the cartridge. Well, in the ROM code in the cartridge is that text screen that you saw that indicated the startup screen with those different bits and stuff like that. And with the appropriate register on the VIC-2, you can point it into the ROM code itself to display that text. So that means, of course, you cannot change that text, right? It's fixed in the ROM code itself. But that's where Matt got really clever, and he used the border region to indicate which bits are actually bad. Now, when it comes to indicating what bits are bad in the border region, you have to count cycles because it's all very timing dependent on whether you're on NTSC or PAL. And I can tell you that I've tested this on NTSC and PAL machines, and it works perfectly. The timing looks perfect, and it is able to line up those indicators with the appropriate text on the screen. Now, this ROM does more than just do what it's doing right there. What I'm going to do is I'm going to quote unquote fix the bad RAM by installing these RAM chips back into the board again. And when we turn on the system, it's going to actually run through the entire test. You can see the border colors rotated through everything. And now it's going to actually test the rest of the RAM. Now there's a caveat here that applies to anything that's running in max mode, and that includes the DesTest cartridge. It is only able to see 4K of RAM on the motherboard. The rest of the RAM is inaccessible, and that is done by the PLA itself, and there's no way around it. So this test, while it's using a March test, and it is doing a thorough examination of all the memory here looking for very subtle errors, it's only able to test the first 4K of memory. The idea would be is you get your system working as well as possible with this test, or even the regular dead test ROM, and then you would upgrade to the full diagnostic test that works when you have a working kernel and basic ROM and all that kind of stuff. And you need to use the diagnostic test harness. That would have access to the entire 64K of RAM. What I would like to see happen, and I need to talk to Matt about this, is it'd be great if we could have a proper DesTest RAM test for normal mode on the 64, where it uses the same March testing algorithm that this is using to test all the memory really thoroughly, as opposed to the really junky pattern-based RAM testing that's in use on the existing Commodore ROM. Now what this is doing is going through and testing all the different areas of memory again, 0 page, stack, and the various areas of memory. And you can see that it's only testing up to 4K. Now what's cool is it will indicate if there are any bad bits in those other regions based on those little green bits over on the right side. So it says 0 through 7 and they're all green. That's telling you everything is good. And if there are any issues found, it will highlight them in those bits. In addition, there's the extra functionality and down the bottom once this part finishes, where it's showing you the time of day off the two 6526s. So if either of those is not working properly, then those times are going to get screwed up. And watch, I'll just take this one out while the system is running and the computer didn't crash, but you notice the TODA at the bottom there now just has a bunch of question marks, and that's showing that it can't read the time of day off this chip. So it's just a little quick indicator to tell you that there might be an issue there. The regular diagnostic ROM that Commodore made also does that, but the dead test ROM does not. So that's just a little extra help in here to see if your 6526s are working correctly. Now, while this is running through, let's just take this RAM chip out here and see what happens. Okay, so it caused an issue right there and it caused a crash. And that's because once the diagnostic ROM gets into this phase where it's showing a full screen of text that is able to update, it is using the DRAM for the VIC2. So the VIC2 is pointing to DRAM. And as far as I'm aware, it's also using the stack and the 0 page for that part of the testing. So me removing this has just caused the ROM to crash. Of course, I can just push this button on here to reset it. And now it's going to indicate that bit 2 is bad. And yeah, that's because I popped this chip out. Now I went through and I did a bunch of different testing on the DRAM on this board by lifting some of the address line pins that go into the DRAM. That creates things called page errors. And right away it was detected by Matt's test instantly. And that's a factor of the March testing being a really thorough way to test the RAM, and it detects all those page errors because of the way the RAM test goes up and down through memory a bunch of times, and it checks for bits that are being flipped when other parts of memory are being written to. So that's where the March testing is really awesome and where a lot of these other tests can fail. The biggest thing about this test is that immediately you get this screen, even if the system has no memory and has other faults, you may end up seeing this screen right here, which I'm pushing reset repeatedly to keep it on here. And it's a good way to know that your 64 is kind of alive. So what I want to do is I want to demonstrate that on a broken 64. Let me just put my ZIF 64 back together here, put the chips back in. So believe it or not, I went through all my 64s that are laying around in the basement here, looking for bad ones, and I really couldn't find any. I found a couple that were in my to fix box, but they had physical problems, like a bad power switch and some bad capacitors that had been ripped off. But once I put those on, the machines worked. But I found this board here, and this was sent in by viewer Henning, and it says number 7 on here because there were a whole bunch of other boards that Henning sent in. I've fixed almost all of them, or I think all of them, but there's this one left. And check out the issue that this particular one has. Powering the system on, we get this screen right here. So we could tell that it's definitely trying to run basic because we have the right colors and everything like that. But we clearly don't have any working text here. So let's start with the regular Commodore diagnostic ROM and let's just see what happens exactly. I have a feeling we're just going to see the same kind of lines. So what you can tell here is that the test is probably working because we can see the box there in the color. It's just lines. We can see the box and the border color and stuff is set. That means the diagnostic test is probably running right now. Oh yeah, okay, so yeah, something's happening there. And let's flip around the cartridge here and go to dead test mode. And let's see what this does. Obviously, we're just gonna get the black screen. I think the machine probably doesn't have any bad RAM because it looks like we're getting into basic. Okay, yep, that looks like the dead test mode there, but clearly we have some kind of corruption. Now let's switch over to DesTestMAX. We'll see what happens here. Well, it took a while for the RetroTink to kind of sync up, but what we can see here is that it looks like it's running there. The corruption looks different, so it's not those lines that we were seeing. If you saw up in the top corner there, it looked like that's the green area where it's telling us the RAM is good. Let's hit the reset button. Aha! So look at that. So I'm pushing it repeatedly just to stay in this mode here, but we can tell the VIC is working. It's able to display the text correctly off the ROM code, not to mention the character set is also stored there, and it's working fine. But as soon as it goes to run in the normal mode, where it's now using the DRAM to hold the text and the character set, we're getting that. Now I think that this cartridge with those lines, and BASIC with the lines, is using the built-in character set on the 64, which is contained in the ROM here. It's not using the DRAM. But DesTestMAX, while it's running in both of its modes, is using a custom character set. And that means it must be copying its character set, which is this one here, single pixel characters, into the DRAM, and then telling the VIC chip to go look at it. So we know we have a different fault on this machine, but it's really quite cool that we know that the machine, well, it's able to display text here. We definitely have a sign of life, and we're not just getting an unintelligible black screen. And it's just a really good indicator to help us know that the fault exists in something to do with the way the VIC chip is displaying its text and graphics out of DRAM. So there are two potential problems with this machine. One is that the VIC chip maybe just has bad contacts or dirty pins or something like that. And when it tries to address the memory directly, it's not working. And the other is that maybe the PLA is bad, and this is one of these later machines with the big PLA chip. Let's start by just taking the VIC out of the socket here. The VIC pins look okay, although they're pretty dirty. But let's just go straight for Deoxy here, and we'll deoxit the socket, my favorite thing to say. And let's see if this does the trick. Now, I've been chatting with Matt about his ROM and asking him maybe, for some new features and other information about it. And one of the things that I asked Matt to do is if he could figure out what is the bare minimum configuration for running the DesTest ROM. So if we look at this longboard here, what can you take out on this and actually have the system still work when it's running his diagnostic ROM? We know for sure that the PLA is required, which this machine is missing right now. We know you need a VIC-2 chip that works, and we know you need a CPU. The bare minimum, you're gonna absolutely need those things. You're gonna need to have a working clock on your system, and the VIC handles the synthesis of the clock signal that goes to the CPU. So this part of the board most likely works. I don't know which of these chips does what, but I think at least this chip and the crystal oscillator is gonna be necessary. When it comes to the DRAM, we know we don't need the DRAM itself, but what about these multiplexers and the other chips? Matt actually took one of his longboards and he socketed every single chip on it and is going through the exercise of figuring out exactly what's necessary to run the DesTestMAX ROM. What's cool about that is once it's in the documentation and you're having issues with your 64, you can get down to the absolute bare minimum configuration to see if the system is working or not. Preliminarily, it seems that you do still need the multiplexers for the DRAM, even if the DRAM is not installed, for the VIC to even be able to work at all. That's kind of an interesting thing. I didn't necessarily think that was the case, but it appears to be the case. So as Matt figures that stuff out, I think it's going to be in the documentation, which we'll take a look at in a second, because he has pretty nice, thorough documentation for the ROM that will help you identify what you're going to need to get a working system, at least to, well, when it comes to the bare minimum configuration. Anyhow, back to the 64, I deoxidated the socket there. Let's turn this on, see if that made any difference at all. It did not. Our only other socketed IC on here is the ROM chip here. Let's just pull this out just in case that's somehow related. And the other thing that's socketed is the clock synthesizer IC here, but you can't take it out. And look at that. The system is working now. Let me just bang on this board a little bit, just make sure it's still absolutely working with the ROM out of there. No, it failed again. So it's not this ROM chip. It's something else on here. Let's hit the reset button here. I'm just going to manipulate chips in areas of the board. So I'm pushing on the VIC chip right now. That didn't do anything. This is a curious problem, I have to say. I don't right away know what might be causing this. And as I twist the board here, we don't get any visual indicators of anything going wrong. I grabbed another one off a different board here. This is the same exact revision and everything. Got to make sure you don't mix and match the VICs between long boards and short boards. They're not compatible with each other. Let's see if that made any difference. Nope. Okay. It's not the VIC. Now what's interesting here, oh, okay, it just started working again. I was gonna say that while this thing is running, even when the text wasn't displaying properly, I could tell that it was actually running correctly because we had all those green areas that were at the tick mark saying that all the bits were good. And by the way, you can ignore that it looks kind of blown out. That's these short boards, for whatever reason, on my RetroTink does that. But you can see it's green, green, green on all parts of the 4K of memory, including the color RAM is all working. So whatever's going on with that corrupted text on this board doesn't seem to affect the ability of the CPU to talk to the RAM and the color RAM. It is some other kind of intermittent fault on the machine. But what could be causing this issue? What's interesting is feeling around on here. Everything is really cool to the touch. VIC is warm, but that's normal. This 6526, which handles the keyboard here, is cool to the touch. But this 6522 is very hot. It is hotter than the VIC-2. It is much hotter than the VIC-2. I don't think that is not normal. From my understanding, the 6526, I think this one is responsible for some amount of switching pages or something like that on the VIC. And I bet you this chip has failed right here. And while the system first boots, we see the clear text and it's coming out of the ROM. I don't think it relies on this at all. I think the VIC is pointed directly to the ROM via the PLA. But when the ROM code tells the VIC to look at the RAM for the character set and the screen buffer, I bet you this is the problem right here. And the fact that it's really hot is a really good indicator. Without this installed, the text is still going to display correctly. And that's because the default configuration where the VIC points to the screen buffer in RAM doesn't rely on this to actually tell it to look to the right spot. I think what's happening is this is stuck and it's probably telling the VIC to look to a different part of memory that's not initialized, which is why we just see a bunch of random stuff. So let me remove this and we'll see what happens. Okay, 6526 is out. Let's turn this on. Aha, look at this. Now we're getting sort of a flashing pattern. And it changes when I hit the board. Oh, look at that. It started working when I touched this area over here, when I took the 6526 out. Let's see if we can get this to malfunction again. Let's touch this area here, what I did before. Look at that. Okay, well, let's look at the schematics. There's got to be something that goes from this 6526 to control what text page is being displayed. And obviously, just touching it with my finger is enough to make it work or not work. Okay, so we're on the schematics. Here is 6526 U2. I don't know, it's not marked on the board what U2 is. I think that's the one I just took out. And the reason why I think this is the one is because here's the user port and it's connected to that. It makes sense that the one I just removed, which is over by the user port, is the relevant one. Let's take a look at what else this thing is doing. So it's handling the IEC port right here, so those signals. But we have a couple outputs right here, PA0 and PA1, pin 2 and 3. Well, let's try to figure out what VA14 and VA15 do. They go off to the other page, and they go right here into the PLA chip. So this is the big PLA on these short boards, pins 10 and 11. And that kind of has me thinking that these might be the two signals that tell the VIC where to look for the character ROM and also the screen buffer. So I installed a socket on this board so we can easily bring the signals up to 5 volts or down to ground through a resistor. This first one here, just touching it causes it to, just touching the resistor causes all sorts of interesting patterns. So grounding this gives us this particular pattern right here. And bringing it to 5 volts makes it work. That's pin 20. Let's just let it get back to the normal screen and I'll take it off. There it is, looks good. Taking it off. Yep, it's messed up. So basically, if the shortboard had a pull-up resistor on this particular signal, then this would probably work all the time. But simply putting pin 2 on that particular 6526 socket to 5 volts through a 10K or I'm using a 1K resistor totally makes it display text correctly. And that definitely told us that this chip right here is absolutely bad. So we'll just draw an X on here so we know that's a bad chip. In fact, I keep forgetting I should be using the silver Sharpie just because it's easier to see. So there we go, bad chip. And I have to admit, in this initial phase of the boot screen, how the text looks correct is very, very useful. And that just helped me realize that it is signals that are output from this 6522 to the PLA, which allow the VIC to display different parts of memory. And I guess on the short boards, you cannot remove the 6526 for the dead test or for this ROM and have it totally work properly, although that screen works fine. So if we take this out and we turn on the machine now, we should get into basic with a corrupted screen, just like we did before. And I installed the 1K resistor between pin 2 and pin 20. And now when we turn it on, we should have a working basic screen. There it is. And it's flashing because the 6526 over here is what handles the keyboard and the cursor flash. Obviously, we're going to have a non-functional user port and IEC port right now because that via is missing. But that's pretty funny that today I learned that on short boards, you cannot operate the system without this via installed or you get corrupted text. That is absolutely not the case on the long boards, and they always work fine. If you have this 6526 removed, you don't get that corrupted text issue. Just shows how little I actually work on these short boards because they're A, really reliable, and B, I just am not familiar with them. But there we go, today I learned. So now we've seen the diagnostic ROM in operation. Let's take a look at the documentation that Matt has provided. It's pretty comprehensive, which is pretty awesome. Oh, and I just forgot to mention that while this particular project is not open source currently, so you can't download the source code, the ROM is freely available, and it's available right now. So I'll have a link in the description so you can take a look at it and download it yourself, try it on emulators, or put it onto one of your dead test cartridges to try for yourself. So in the documentation, Matt goes into the fact that this operates in Ultimax mode or Max mode, which is like the old Commodore Max. And that involves pulling the /game signal on the cartridge port down to ground, which asserts that signal, tells the PLA you're going to be running in Max mode. And then you need an 8K EPROM, that is the actual ROM code itself that replaces the kernel ROM. And that's what this cartridge is doing right here. So then Matt goes into the different phases of the initial diagnostic test that's running with the different border colors and then how it indicates the bad bits. And it shows an example of the ROM checksum that you can get if your EPROM is not working or say the cartridge connector is dirty or something like that. And then we have the screens that are showing it working. And if you do have some bad bits in part of your RAM, that's what it looks like. And it actually will indicate the bits there, but it will still use the border region to also indicate the bits, just in case there's corruption in the text screen. Then you know right there that it's talking about bit 1 and bit 6. There's also the wall of shame, which will show all the bad memory locations and what happened. So it will tell you what was actually written and what was read back from those memory locations to help you identify if there's any crosstalk between the data lines or the address lines. The ROM has the ability to also detect unexpected IRQs and non-maskable interrupts, which would happen if you hit the restore key. But if you have like an electrical fault on your machine, it's possible that some of these could be triggered while the test is running. It is also possible that you can run this diagnostic ROM directly plugged in the motherboard as a kernel ROM replacement. Of course, when you're in kernel mode versus dead test mode, you have access to all of the RAM versus just the 4K in max mode. Not to mention the VIC chip is forced to access the DRAM on the motherboard at this location versus the ROM itself. So you're not going to be able to get that mode where you actually have working text even if your RAM is not working. And here's where it mentions actually in his documentation that it uses CIA2 to pick which 16K bank of memory is used for the VIC2 to look at. And that's exactly what was just wrong on the motherboard that we worked on. And then Matt talks about the methodology used, including the March testing that was used, and it came from this particular deck here, which I've actually looked at before. And Matt re-implemented this in 6502 assembly. And as a side note, Matt has a version of this that is for the SwiftLink. And when you have a SwiftLink, which is basically a cartridge serial port type device, then what you get is additional information displayed on the serial output. Now, it'd be nice, and I asked Matt about this, if he could bit bang the user port as well to do this at, say, 300 or 1200 baud, and it is totally possible. But right now, it's the SwiftLink mode that is the only mode that can work. So if you have a SwiftLink cartridge, then you can get this stuff as well. But I can't demonstrate this because I don't have a SwiftLink, and just wanted to let everyone know that it does exist. So there we have it. I just really wanted to show off how awesome this new test ROM is that Matt created, and I think it's pretty exciting. And I have to admit, I'm going to be using this for all future repairs instead of the dead test. I see no reason to use a dead test ROM over this in any circumstance. And well, this is just going to keep getting better as Matt fine-tunes it and also comes up with additional documentation about the minimum configuration that your 64 needs to be in for this to even run. I'm going to make sure to tell him that on short boards, there seems to be an issue if that CIA2 is removed, at least when it comes to displaying the text, like we just saw. So that's a little tidbit that's probably good information for anyone trying to troubleshoot their machine. So if you want to test this out for yourself, there's a link below to Matt's website, so you can download the code and the documentation and give it a try yourself. I highly recommend it because this is pretty exciting in the world of Commodore 64 diagnostics. So thanks very much, Matt, for coming up to me at VCF Midwest and thinking about me when it came to this diagnostic ROM. And I hope this ignites some kind of a thing in other 8-bit systems where people start writing modern and good diagnostic ROMs for them. Don't forget to check out the GitHub repos for all the ROMs that David Giller has written for me on the other systems, because that code should be somewhat transportable to other systems, and then maybe we'll have much more reliable diagnostic ROMs for other things. Commodore PET comes to mind as a system that has bad RAM tests right now, and I've been stuck with page errors before causing all sorts of weird things on PETs, and it would be awesome to have a ROM for that that could also do a comprehensive RAM test for those machines. So that's going to be it. So if you like this video, I'd appreciate a thumbs up. Huge thanks to my supporters. Their names are going up the side of the screen. They make it possible to do this full time. You can become a supporter at the link in the description below. I now support YouTube memberships as well, not just Patreon. And actually, I'm getting a bonus right now if you sign up for that. If you don't like using Patreon, then memberships might be a good alternative. Although I think it's generally going to be the same stuff on both. I'm going to post early access to videos and behind the scenes videos to higher tiers, things like that. So that's going to be that. So I hope you enjoyed this video. And if you did, thumbs up, all the usual YouTube junk. And stay healthy, stay safe. And I'll see you next time. Bye-bye.